A student increases the intensity of a monochromatic light beam shining on a metal surface, but the frequency remains constant. What effect will this have on the kinetic energy of the emitted electrons? Leave a comment if you think you know what the answer is. This question is referencing the photoelectric effect, where a photon strikes an electron and then that electron gets ejected from that atom. And I have a sketch here showing a photon striking an electron and then that electron getting ejected. In order for this to happen, the energy of a photon, which we can find via the equation h times f, where f is the frequency of the photon and h is Planck's constant, that energy has to be greater than the work function of the electron, and the work function is just the minimum amount of energy required to eject that electron. And then the ejected electron has a kinetic energy that is equal to the difference between the photon's energy minus the work function. So whatever energy is left over from that photon after it strikes the electron is going to go into the kinetic energy of that electron. And as the kinetic energy goes up, the speed of the electron goes up. The question is just asking us what happens when the intensity of a beam of light is increased. If you draw a wave to represent this light, and then you increase the intensity, the thing that changes with the wave is the amplitude. So notice how the frequency and the wavelength stay the same, but the amplitude has increased. And when the amplitude of light or the intensity of light increases, what's changing is the number of photons. So we basically have what we've drawn here happening more. And since the frequency of those individual photons is not changing, then that means that the kinetic energy of the ejected electrons is also not changing. So we're ejecting more electrons, but the kinetic energy of those electrons is unchanged, which means C is the correct answer.